Hi folks, welcome back to 7.4. And so when we left off here, we were looking at finding the angle between two vectors. And that's actually where we're going to start again. We're going to go ahead and practice one more example of how to find the angle between two vectors. Okay, so we have find the angle between a equals 4 comma negative 3 and b equals 1 comma 2. And so what I want to start off with this time is actually the diagram, so we can kind of see like what we're looking for, okay? So I've got a y-axis, I've got an x-axis, and let's do vector A in the blue, and we'll do vector B in the purple. So B, I know, is from the origin, I'm going to go over 1 and up 2, so that's going to look something like that. And that's our vector B. For vector A, I have to start from the origin. I'm going to go over 4 and down 3, so that's going to be something kind of like that, and that's vector A. And what I'm looking for is this theta in between. Now, I know that the way I drew it probably looks like a right angle, but my diagram is definitely not to scale, and it's okay if yours is just a sketch, but we want to make sure that we can find this angle exactly using our formula, okay? So we've got cosine theta equals a dot b over the magnitude of a times the magnitude of b. So I've got 4 times 1 plus negative 3 times 2, that's my dot product, over the square root of 4 squared plus negative 3 squared to find the length of vector A, and then the square root of 1 squared plus 2 squared to find the length of vector B. Now when I type those all into the calculator and simplify, in the top I'm going to get 4 plus negative 6, which is negative 2. And on the bottom I'm going to get 5 root 5. And so what I'm going to do here, 5 root 5. So what I'm going to do here now is, because I don't want cosine theta, I only want theta, I'm going to take the arc cosine, or the inverse cosine of the number I found. And when I do that, I'm going to get an angle of about 100.3 degrees. All right, so this is our theta, and that represents the angle that is in between vectors A and B. Okay, so let's move on to a second kind of question, a type of question where you have two vectors and you're trying to figure out, are they parallel, are they orthogonal, or are they neither? And so what that means is you want to find the angle in between them, but you're looking for specific numbers. So if angles are parallel, that means theta equals 0 or theta equals pi, meaning they could be in the same direction with exactly the same slope, or they could be in different directions, opposite directions, but with the same slope. Orthogonal means that the angle in between them is going to be 90 degrees, or pi over 2, and anything else. All right, if theta equals anything else, then it's going to be a case of neither. So let's take a look at our two vectors and plug those into our formula. So I've got cosine theta equals a dot b over magnitude of a times magnitude of b. And I'm going to plug in my numbers. So in this case, I have 6 times negative 4 plus 18 times negative 12 over the square root of 6 squared plus 18 squared, and then times the square root of negative 4 squared plus negative 12 squared. Now these numbers are a little bit bigger than the last problem, but the same process is still going to hold true. So let's simplify. We've got cosine theta And when we simplify on the top, we get negative 240. And when we simplify on the bottom, we actually also get a 240. That means that cosine theta equals negative 1. And so when we think about our unit circle, where is there an angle that has an x value of negative 1? That's going to be pi. And so because the angle between them is pi, that means that A and B, all right, so you could say A hat and B hat are parallel vectors, and they point in opposite directions. Okay? All right. So let's go ahead and take a look at example 6. So example 6 is super similar. I have determined whether two angles are parallel, orthogonal, or neither, and I've given two different vectors this time. So let's plug those into our formula. So A dot B will give us something like that, over the square root of a squared, or square root of a1 squared plus ba2 squared. That'll give the length of vector A. And then times the square root of 6 squared plus negative 4 squared. That will give us the length of vector B. And so when we clean up the numerator here, we're going to get 0. And when we clean up the denominator, we will get 4 plus 9 is 13, and then 36 plus 16 is going to give us 52. All right? And now the numerator is actually the more important part, because anytime I have 0 divided by something, I'm going to get 0. And so what that really means, I have cosine of theta equals 0. And when that happens, I know my one solution is pi over 2. And that means that A hat and B hat are orthogonal to each other. Okay? And if we were to do a rough sketch here of what that looks like, so we've got our xy axis. Let me do that again. That was pretty bad. So we've got an x-axis and we've got a y-axis. That's better. And we're going to do vector A in blue. So 2 and 3 is going to give me something like that. And vector B is going to be 6 and down 4. So vector B is going to be down here. And the angle in between them is actually a 90-degree angle. Okay? All right, so let's move on to another type of application of the dot product. The component, all right? So let theta be the angle between two non-zero vectors A and B. The component of A along B, and the way that we write that is comp little b regular A, is given by the following formula. The component of A along B is the magnitude of A times cosine of the angle in between them. Now, I want us to make sure we know what this means. So when we're talking about the component of A along B, we want to look at the part of A that is in the same direction as B. All right? So let's take a look at a visual of what that means. So over here, I have two different diagrams. So if I want the component of A that's pointing in the same direction as B, what I want to do is imagine that B is the horizontal. Okay, so it might be helpful to even tilt your head or turn your screen a little bit, but let me try and use the same color. Okay, so if A is pointed in that direction, the part of A that goes along B is this part right here. So when you find the number that is the component of A along B, you're finding out how long that light blue line is. And if it's in the same direction, it's going to be bigger than 0. But if it's in the opposite direction, like we have in the second diagram, it's going to be less than 0. All right, so let's take a look at example number 7. Okay, so example number 7 says, given B and C, I want you to find the component of B along C and the component of C along B. And that should be switched. This should be little b and a regular C. Okay, so let's do part A here. Finding the component of B along C. So this is the part of B that is in the same direction as C. Okay. So let's plug things into the formula. So the component of B in the direction of C equals B dot C over the magnitude of C. And so when we plug that in, we're going to get 3 times -1 plus 4 times 5 over the magnitude of C is -1 squared plus 5 squared. And so when we clean that up a little bit, we're going to get 17 in the numerator, and we're going to get square root of 26 in the denominator, and that is about 3.33. Okay, so let's do a quick diagram of what this looks like. So I've got my x-axis here. I've got my y-axis here. And I'm going to do vector A in blue, or vector B in blue. So I'm going to go over 3 and up 4. That's going to be like vector B. And I'm going to do vector C in purple. So I'm going to go -1 and up 5. Okay. And so if I imagine the purple line as the horizontal, then the part of the blue line that is in the direction of the purple, I would drop this perpendicular here. And this part right here should have a length of 3.33. Okay? All right, so we're going to stop here for video 2. Come on back where we finish this problem and a few more applications for part 3.